So today we are going to discuss ray optics. So one of the most important topics. So from this chapter, we get 2 or 3 questions. So this ray optics we can divide into some parts. That is, so we discuss mainly in ray optics, reflection and refraction we discuss. So, and in this, what are the topics you have to remember? One is mirrors. In these mirrors, we have plane mirror, concave mirror, convex mirror. These are the 3 mirrors you have to revise. And after that, lenses. So concave lens, this and convex lens, plano-convex lens, plano-concave lens, and combination of lens and mirrors, and prism. So next, we have to you have to revise the prism and also instruments. So these are the things you have to remember. In prism, this is deviation, and also, so this one is what the deviation you have to discuss, and prism formula, and so all these things you have to. Then once I write here, so that is in the ray optics. In ray optics, you have to remember one is what plane mirror, concave mirror, convex mirror, okay, and also this is lenses. In these lenses, you have convex lens, concave lens, combination of lens and mirror, and also prism. Okay, so these things you have to remember, and optical instruments. So, and this combination of lens and mirrors, and also this one, the refraction at single chord surface. So then these things, if you revise, then so definitely you get 2 or 3 questions from this, so you can answer. Let us see some questions. Let us see. Once we come to the mirror, plane mirror, what are the things you have to remember about the plane mirror? So if the mirror, plane mirror, if you take, what is the minimum size of the, so this one person to see his full image in the plane mirror is half of the height of the person. That you have to remember. And if the person is in the middle of the room, he wants to see the backside wall in the front side mirror. So then the minimum length of the mirror must be equals to 1/3 of the size of the person. So this 1/3 of the size of the, so this one is this one backside wall. So these things you have to remember whenever a person is in the middle of the room and he wants to see the backside wall. So this one is height of the wall in the front side mirror. So minimum length of the mirror must be equals to 1/3 of the size of the wall. So these things you have to remember. And also one more, suppose if the mirror is at rest and object is in motion, so image moves. So the same velocity but in opposite direction. Suppose if the object moves x distance, image moves same x distance but in opposite direction. Okay, now suppose if the mirror moves, if the object is at rest but mirror is moving, so then, so image moves with, so let us take what mirror moves double the velocity of, so this one is what, if it is moving with velocity v, then image moves with velocity double the velocity of the mirror but in the same direction. So these points you have to remember. If it is perpendicular to the, so this one is what mirror, if the object if the mirror moves perpendicular to the object, then image moves double the velocity of the mirror. Or, and also if the mirror is in, this one is what kept at rest and the object is moving, image moves opposite of, this one is what velocity, and but in the same magnitude but in the opposite direction. So these points you have to remember. And if the object moves in the same direction, I means what, in the plane of the mirror, if the object moves, image moves, so with same velocity but in the same direction. Whenever, suppose this is the mirror, if I move what perpendicular to the mirror, then image moves so opposite of this. If I move parallel to the mirror, if I move, then image moves same velocity but in the same direction. These things you have to remember. And so one more point let us take. Then based on this one, we discuss one question. Let us take one question we discuss. So now let us see this question. So a plane mirror is moving with velocity. So this one plane mirror, let us take what this is, the mirror is moving with velocity 4i cap plus 5j cap plus 8k cap. This is the velocity of the mirror. A point object in front of the mirror moves with velocity. This one is what velocity of the object. It is moving with velocity 3i cap plus 4j cap plus 5k cap. This is the velocity of the object. Now, here the k cap is the direction along the normal to the plane mirror. Then, so this is what normal to the plane mirror is what, this is k cap. Then, along the normal to the plane mirror and facing towards the object. So this is what facing towards the object. Then, so it is in xy plane and it is what perpendicular to this is what k cap. Then, what about the, so velocity of the image? So mirror is moving here, mirror is moving, and as well as what object is also moving. First we take what mirror is at rest and fixed and object is moving. When object is moving with velocity this one, so image moves with what velocity? Opposite direction. That too perpendicular to this plane mirror, only it gives what? Opposite, but remaining things are same. Then velocity of the image due to this object. So velocity of the image due to the object is 3i cap plus 4j cap minus 5k cap. So this is what perpendicular to the mirror only, it is reverse. But the remaining things are what? Same as what? So this one. Now, if the mirror is moving with velocity, mirror, so velocity, then this is what? Image. Image formed by, so motion of the mirror. So then, so this should be equal to velocity of the image due to this mirror motion. So whenever it is what 4i cap plus 5j cap, and this is what 8k cap, it is what perpendicular to this one. Whenever in the plane, if it is what moving, then what happens here? So this 4i cap, suppose if this is, there is a mirror, if the object is moving, so let us take what this is a mirror, object is at rest. So if the mirror is moving this way, then image moves, so double the velocity. But if the mirror is moving in this plane, then there is no change in the velocity of this one. Therefore, what we get? Only this part is what? Nothing will change. Only this one becomes what? 16 k cap in the same direction. So now double the velocity of this one, only perpendicular to the mirror only changes. Therefore, what about the final velocity of the image is equals to, we can write as what? 3 I cap plus 4 j cap. If you add these two, then it becomes what? 11 k cap. This should be the answer to this question. You have to remember whenever, so this one is what? Mirror is moving, then image moves double the velocity, but only perpendicular to the, so this one is what? Plane of the mirror. The remaining things what? Won't change. But if the object is moving perpendicular to the mirror, so whichever is the perpendicular to the mirror, that will reverse its, so this one is what? Direction, but remaining things are what? Same as that. So this one is important, you have to remember, right? Okay, we'll go to the next question. Let's take this. Right. Next, we go to the next question. Let us take even. So now one question based on the this one, if I take what about the mirror, if I take, yes. Now let us take a ray reflected successively from two plane mirrors inclined at certain angle undergoes a deviation of 270 degrees. After two reflection, the number of images observable is. Now, let us see if two plane mirrors are at an angle theta, the number of images, we can take it as what? Number of images is 360 by theta. If it is the even number, then we have to subtract 1 from this one. If it is what? Even, we subtract. If it is the odd, we take it as what? 360 by theta. Now, let us come to this one. And one more, if two plane mirrors, one important point you have to remember, if the two plane mirror, before discuss this question, let us take what are the things required for this. Suppose if the two plane mirrors are at an angle theta, if let us take, it is making an angle alpha, a light ray falls on one mirror. So let us take what this is the first mirror, it falls with an angle alpha, then reflect and comes back like this. So now, what about the deviation occurred? The deviation is equal to, you have to remember 360 minus 2 theta. The deviation occurred is independent of angle of, so incident by the light ray. It does not depend upon this one, it depends on, so the angle between the two mirrors. Therefore, the deviation is equals to, what is the formula? We have to remember 360 minus 2 theta. This deviation is independent of whatever the angle of, so this one angle, the light ray is what? Falling. Now we come to this question. So a ray reflected successively from two plane mirrors inclined at certain angle undergoes the deviation. But what is the deviation is given in the question? 270 degrees. And so after two reflection, the number of images observed, number of images is asking. So to calculate the number of images, we required, so this one is what? Angle between the two mirrors is required. Then what you have to do? First, we have to calculate the angle between the two mirrors. So, but deviation is given. As the deviation is given, I can calculate the angle between the two mirrors. Then, what is the deviation? This is given 270, which should be equal to 360 minus 2 theta, or 2 theta is equal to 360 minus 270 becomes 90, then theta becomes, it is 45 degrees. Then, now we got the angle between the two mirrors we got. As angle between the two mirrors we have, then, so the number of images is 360 by 45. Then we have 9 5s are 9 4s are 5 8s are, that is 8. As it is what? 8 is an even number. Then the number of images formed is 8 minus 1. That becomes what? 7. Therefore, the total number of images formed is 7. In this, what you have to remember, most important thing is the deviation. If two plane mirrors are at an angle theta, what are the important points you have to remember? If two plane mirrors are at an angle theta, so the deviation does not depend upon the angle of, So angle, the light ray is what falling. So that is of one important. And the second important thing is deviation is equal to 360 minus 2 theta. And the number of images is, so 360 by theta, if it is even number, we subtract 1. Based on that, we discuss this question. Okay, take this. Right. Next, we move on to the next one. Let us take, yes. Now, let us come to C. Yes. So here, a monochromatic light wave with wavelength lambda 1 and frequency nu 1 in air enters another medium. So if the angle of incidence and the angle of refraction at the interface are 45 and 30 respectively, then the wavelength is lambda 2 and frequency this one of the refracted wave. So this is refraction based on the refraction. What are the things you have to remember to do this one, and what concept is required is, let us take, so whenever this is the surface which divides the medium. So let us take what mu1 and mu2 we have. Let us take in this. So a monochromatic light wave, this is what lambda 1 is the wavelength of light. Then it is going like this. So the angle that is making is 45 degrees. And this becomes what 30 degrees. Whenever light ray is traveling from rarer to denser, it bends towards the normal. So as the angle of incidence is more, that's why it must be the rarer medium, and this is the denser medium, then 45 and 30. So then the wavelength lambda 1, this wavelength is lambda 1 and this wavelength is lambda 2. Okay. So, and also this is what wavelengths are given, and also frequencies are also given. Frequency nu 1 and frequency nu 2. Right. So we know that one very important thing, whenever a light ray is traveling from one medium to the another medium, as the medium changes, so which one changes? Frequency remains same, velocity changes, wavelength changes. Of course, this refractive index changes. But which one won't change? As the light ray is traveling from one medium to the other, so frequency remains constant. As frequency is same, nu 1 is equal to nu 2. Then from this, so we can say, then what should be the, this one is what can't be the answer, because nu 1, nu 2s are different. Even this one is also can't be the answer, but the answer is there in between, in this B or C is the answer is there only in B or C, right? Because frequencies are equal. Now we can take, so by using this one is Snell's law, we can take. So what about Snell's law? Snell's law, you have to remember refractive index into sine of particular angle in that. So mu1 into sine 45, the refractive index into sine of that particular angle in that medium should be equal to refractive index into sine of that particular angle in that medium. Means this is sine 30. Then, so this is mu1 into 1 by root 2 should be equal to mu2 into 1 by 2. Now, mu1 by mu2 should be equal to root 2 by 2, which should be equal to 1 by root 2. But mu and lambda, how they are related? One important thing you have to remember, mu is equal to C naught by Cm, velocity of light in vacuum to velocity of light in a medium. Or we can write it as here. So this is equal to n into lambda naught by n into lambda m, where n I'm taking what frequency. Then as frequency is constant when light ray is traveling from one medium to the other, then mu proportional to 1 by C proportional to 1 by lambda, must have to remember proportional to 1 by sine of critical angle. This is what, where C is the velocity of light and C is the critical angle, and also it proportional to temperature as temperature increases. So this is, so we can take it as what in this, one second. So now This one is proportional to density. As density is what more, refractive index is more. That's why diamond is having what high density compared to air or vacuum. So proportional to this is what 1 by temperature. As temperature increases, density decreases, even refractive index slightly decrease. So these things you have to remember. And from this is the points you have to remember. Now we come to the question. Mu1 by mu2 is equal to 1 by root 2. As mu and lambda is inversely proportional, therefore lambda 2 by lambda 1 is equal to 1 by root 2. Then I can take it as here, lambda 2 is equal to lambda 1 by root 2. So this is the correct answer for this one. B is the correct answer. Then lambda 2 is equals to, because mu is inversely proportional to lambda. So that's why mu1 by mu2 instead of that, lambda 2 by lambda 1, I can get this. This is the way you have to do this type of question. But you have to remember Snell's law and also the relation of mu and lambda, then we can. Right. Next, we go to the next question. Yes. So another important question. So that let us see. Whenever this is a standard point you should remember. Whenever light rays traveling from, this one is what air with an angle alpha and enters into the medium. So it is what same one question is also the similar to this. Let us come to this one. And so light rays what entering this one and enter inside, and it is what grazing. Then what should be the maximum angle of this one such that it grazes? So you should remember this is the standard formula you have to remember. Then I or alpha, this alpha is equals to, I'll change the color, right? So then this is what sine alpha is equals to, we can get is equal to under root of mu1 square minus mu2 square, or alpha is equal to sine inverse under root of mu1 square minus, this is the maximum angle of this one. How do we get this is, so you can use the Snell's law. So as if it is like this, if it is given this way, and this is what critical angle, this becomes what 90 minus C, and this is 90. Use Snell's law at this position and also at this place. So we can take, 1 second, I'll change the color. Then how do we get this one? So 1 into sine alpha is equal to mu1. So into sine of 90 minus C, which is equal to mu1 cos C. And also this is sine alpha. And also if I use Snell's law, mu1 into sine C should be equal to mu2 into sine 90. Then, so our mu1, once again I'm writing this one here, mu1 cos C is equals to sine alpha. Then, so square and add, we get this question, this answer, sine inverse, what do you get? Root of mu1 square minus mu2 square. This is a standard formula, should have to remember. What should be the maximum angle of incident such that it should not come out? Then that is sine inverse root of mu1 square inside minus mu2 square. This formula should have to remember. Then we go to the next question one. Then let us take, we go to this one. After that we come back again. So let us take in this, what is the question is given? What should be the angle? This is theta is asking, for which light ray grazes along the wall, should not come out. So then we can take it as what sine theta should be equal to under root of mu1 square minus mu2 square, which should be equal to, what about this is what mu1. So a transparent solid cylindrical rod has a refractive index 4 by root 3. It is surrounded by a medium of refractive index 2. This is what 4 by root 3. And also we have, this is given as what 2. Then, so now let us take, I'll change the color. This is 4 by root 3. And also this is what 2 is given. Okay, right. Then what you can take, so now if I substitute in this, that is equals to, this is 16 by 9, 3 minus this is 4, which should be equal to 16 minus 12 by 3, which should be equal to, so let us take what, this is 4 by 3 under root, which should be equal to 2 by root 3, or theta is equal to sine inverse 2 by root 3, which should be the answer. So like that, you have to remember. So this is what standard formula should have to, what should be the maximum angle such that it should not come out. So just you can remember this one. Yes. Right. Even, so you can take even this. So based on that formula, this is one of the examples of that formula. Right. Next, we go to the next question. Let us see. So another one. Yes. Even about this is the mirror. Let us come to this. The distance of an object from the pole of a concave mirror is equals to its radius of curvature. The image must be. That is the question. Let us see the distance of an object. This is a mirror. So concave mirror question. The distance of an object from the pole of a concave mirror. So he's asking from the pole, this is the object. He's asking about, so this is what distance is equal to. The distance of an object from the pole of a concave mirror is equals to its radius of curvature is given. So this radius of curvature is r. If radius of curvature is r, its focal length is half of the radius of curvature for the plane mirror. This is concave mirror. Now, so then what should be that? The image must be. You have to remember what is the mirror formula. To do this question, what are the things should be remembered? So mirror formula. What is the mirror formula? 1 by f is equal to 1 by v plus 1 by u. Sign convention should be taken. But whichever the thing you are calculating, don't give sign convention and don't give the value and don't give the sign convention. But anyhow, we don't know that one. Yes, 1 by f. What is the focal length of the concave mirror? Concave mirror, so for concave mirror, this focal length is negative. Therefore, f is equal to r by 2. We can write 2 comes to numerator. Then 1 by v, we have to know where we get the image. So the position of the image gives what, whether it's the real or virtual. Then plus 1 by u. But object distance is given as the object is in front of the mirror, then we can take it as what, minus r. So this is what object distance. Then 1 by v is equals to minus 2 by r plus 1 by r, which should be equal to minus 1 by r, which should be equal to minus r. Where do we get the image? So anyhow, this image will get here. So anyhow, this is what standard thing. Even you can do what like this, or directly we can do. So that is what if the object is at the center of curvature, because so exactly radius of curvature means what, it is center of curvature. If the object is at the center of curvature, image is also at the same position, but it is what inverted we get. So this is what inverted. So then we can take it as what inverted we get. How do we know the inverted? Magnification is equal to minus of v by u, or height of the image by height of the object. Minus v is given minus r, u is given minus r. Sign convention should be taken. And the height of the image, I don't know. Height of the object is, it is erect object. That's why it is what positive. Let us take what this way, h naught. So minus minus cancel, r hi is equal to minus h naught. Height of the image negative means what? It should be inverted. So that's why you will get what inverted. Then what are the things you can remember? It should be what? Inverted, and also then So what type of image is this? A real image, or the image must be, what type of image is that? Is that the real image or not? Yes, because whenever so image formed in front of the mirror, then we can say it is the real image. If the image is formed this one is what behind the mirror, then we can take it as what it is, virtual image. But in the case of lens, it is the reverse. Okay, so that way you have to remember. So or directly we can say, if the object is at the center of curvature, image is also at the same center of curvature in front of the mirror. That's why also we can say it is the real image. If it is not exactly R, if it is given some other value, then we have to follow this one. Otherwise, you can remember, if object is at the center of curvature, image is also at the center of curvature. Okay, that's enough. Right. We go to the next question. Let us take, yes, even this is also concave mirror. Let us take, so a concave mirror has focal length 20 centimeters. The distance between the two positions of, let us take what this is a concave mirror of focal length is 20 centimeters. The distance between the two positions of the object for which image size is double the size of the object. So how can we take this one is what object, but one important point you have to remember. So this is what object distance. What is asking? So the distance between the two positions of the object for which the image size is double the size of the object. One thing you have to remember based on this one. So what are the things you have to remember? Concave mirror gives, so real image it gives and also virtual image it gives. Even concave mirror, let us take what these are the points you have to remember. Concave mirror gives real, so this is what magnified it gives, and also virtual and also magnified. So, but it is given, so image is size is double the size of the object. That means magnified means what, it is double the size of the object, and also it is what doubled. But he's not saying whether it is what inverted image or erect image is not saying. That's why there are what two possibilities are there for this question. But if it is what convex mirror, what are the things you have to remember? So in this convex mirror, it gives the virtual image and also diminished it gives. So it is giving compulsory. If a mirror is not given also, directly we can say as it is what double the size of the object means. So it's compulsory, it should be the so concave mirror. Right. Convex mirror gives virtual, so diminished. What are the things you have to remember? Focal length of this convex mirror should be positive. Focal length should be negative. You have to take. And for real image, so V should be negative. For virtual image, V should be positive. So you have to take what in front of the mirror if U is given. So if the object is what given like this, so we can take it as what U is negative, we take. Okay. So this one is what negative. Now, let us come to this one. So, in this, suppose you have to remember one important point. This is the mirror or this one is what? For optical surface. So, if the object is here, from this optical surface, then we can measure from the object ray start, then we can measure like this. U should be taken as what? Negative. But sometimes, suppose there is so this one is, let us take, if there is a converging beam is given. So in that now optical surface is kept. Now the object is what here. So this object is the object. The rays are entering like this. Then you have to take what from pole. You have to take U should be taken as positive. You have to take. So this we call it as what it is. So this one is what? Here is what real object, and this one we call it as what for virtual object. Whenever intersecting and it is forming the object, then object, this one distance should be measured from pole, then U should be taken as what? Positive. In this case, virtual object, we take it as what? Positive. For real object, we can take it as what U is. From this ray start, then we can take it as what? This is the way we measure. It is what? Negative, we take U. So if this type of case, you have to take what? Object distance is positive, you have to take for virtual object. Okay, now we come to, these are the things you must have to remember. So before going to do the question, so what are the other points you have to remember to do this question? So that is important. Now we come to, let us take, so this question. So let's take what here, concave mirror gives, it's a double the size of the object means, so it is not given clearly whether it is the real image or virtual image it is forming. That's why two possibilities are there. Then what is the formula for object distance? You can write, so 1 by f is equal to 1 by v plus 1 by u. If I multiply with u, so throughout the equation, I can get, so u is equal to f into 1 minus 1 by m. Even you can take, so this formula, if you multiply with u throughout the equation and m is equal to minus v by u, I can get this formula, but you have to remember this standard formula. So then what you have to take, u is asking about object distance, and two possibilities we are getting. One is for this is double the, real image also gives for double, and also virtual image also gives for double. So that's for two positions. So you can get this condition. So u1 is equal to focal length of that concave mirror is, so this minus 20, that focal length, 1 minus. So this one is, this is what magnification. Let us take what magnification is double the size of the object means what it is. Let us take what first I am taking, it is a, so real image. Real image is, as it is what real image is what inverted, we can take it as what minus we can say. Then, so u1 is equal to minus 20 into 1 plus 1 by 2. Then u1 is equal to minus 20 into 3 by 2. Then u1 is equal to minus 30. So minus shows what it is in front of the, so mirror. u1 we got, one position of the object is 30 centimeters. So then it may give what, it's a virtual image also, double the size of the, this one is what object. Then I'll change the color. So let us take even u2 also we can take minus 21 minus 1 by. So this is double, this is what virtual image. So as it is the virtual image is what plus 2 magnification, then u2 is equal to minus 20 into 1 minus 1 by 2 becomes 1 by 2. Then it becomes what? u2 is equal to minus 10. This one also forms in front of the mirror. One is getting what at 10 centimeter minus, another is what we are getting at, so 30 centimeters we are getting. Then what is the distance between, so two objects, the distance between the, so object is what, 30 minus 10 becomes what, 20 centimeters is the answer. Okay, this is the way you have to remember, because, so what are the things you have to remember? So this is what positive concave mirror focal length, and magnified, it gives what magnified image, real magnified and also virtual magnified it gives, whereas convex mirror gives what, virtual and diminished it gives. And the formula u is equal f into 1 minus 1 by m, substitute for real image, so and also virtual image, then you get the two positions, and distance difference between those two gives the distance between the two positions of the object. Right. Next, we move on to the one combination of lens and mirror we can take. So let us take this combination of lens and mirror. Then one question will take, let us see this one. It's a combination of, so lens and the mirror, and also most important, this one concept we discuss here. A convex lens of focal length 20 centimeters is placed in front of a convex mirror with their principal axis coinciding. The distance between the lens and the mirror is 10 centimeters. So now let us take a convex lens. So this one is what convex lens this is. So focal length is 20 centimeters. It's the combination of lens and the mirror. So a convex lens of focal length 20 centimeters placed in front of a convex mirror. This is the convex mirror. So this is convex mirror. So with their principal axis coinciding. This is coinciding. The distance between the lens and the mirror is 10 centimeters. This distance is 10 centimeters. The distance between lens and the mirror is 10. A point object is placed on the principal axis at a distance of 60 centimeters from the convex lens. So this is the point object is placed at what distance? 60 centimeters from the lens, from the convex. The image formed by the combination coincides with the object itself. Whatever the final image is forming on the object itself. This is what one of the important concept you have to remember. So standard thing you have to remember, whenever final image is coinciding the object itself, the condition is first image formed by the lens should be at the center of curvature of mirror. This must have to remember. So first image formed by lens should be at center of curvature of mirror, This should have to remember this one. So the first image formed by the lens. Then what about the first image formed by the lens? First we have to calculate where do we get the image. So object distance is there, focal length is there. I can calculate where do we get the image formed by the lens. Then what is the lens formula? 1 by f is equal to 1 by v minus 1 by u, 1 by, as it is a convex lens. For convex lens, focal length is positive. Concave lens is focal length is negative. Then we can take it as what? Plus 20. Then 1 by v, I have to calculate. Don't give sign convention. So 1 by u. U is minus 60 as the object is in front of this one. It is not intersecting. If it is intersecting and forming the object, then we call it as what? Virtual object. In that case, you should have to take as positive as u. Then now 1 by 20 is equal to 1 by v plus 1 by 60. 1 by v is equal to 1 by 20 minus 1 by 60. LCM is 60. This is 3 minus 1. Then so 1 by v is equal to 2 by 60, which should be equal to v is equal to plus 30. Plus means what it is? That side we are getting, right side. Then, so image formed, this is what? At 60 centimeters. That means I'll change the color. Then, so it is forming at 60 centimeters. This is about at 60 centimeters you are getting. Okay. So then, now, let us take what? Not 60, it is 30 centimeters. Yes. This is what 30 centimeters we are getting. So, the first image formed by the lens is at 30 centimeters, but this total is 30, but already this is 10. Then what should be this one? Tell me. This is 20 centimeters. So, as this is what 20 centimeters, so then I said no. First image formed by the lens must be at the center of curvature of the mirror. That means this should be the center of curvature of this mirror. As the radius of curvature is 20 centimeters, what is the focal length of that mirror? R is equal to 2f, where f is equal to 10 centimeter. That means the focal length of this convex mirror is 10 centimeter. This is the way you have to remember. This is what very important. Whenever final image is coinciding the object, the first image formed by the lens should be at the center of curvature of mirror. Okay, by that we can get. Similar way, one more question we'll discuss. Let us take, yes. Similar way we can say, yes. So similar to that question, let us take what this one more question. We practice this. A convex lens of focal length 15 centimeters, convex lens of focal length 15 centimeters is placed in front of a plane mirror at a distance of 25 centimeters. This is the plane mirror at a distance of 25 centimeters from the mirror. where on the optical axis and from the center of the lens should a small object be placed such that final image coincides with the object itself. Then where should we place the object such that, so this one is asking which one, where on the optic axis and from the center of the lens should a small object be placed so that final image coincides with the object. The same as the previous, but only the difference is instead of convex mirror in the previous question, so this is the plane mirror is given. Now what to do? Same, this one is what concept, and same, this one is what formula we used. So one is the first image formed by the lens should be at the center of curvature of the mirror. But what type of mirror is this? It is a plane mirror. What is the center of curvature of the plane mirror? Infinity. That means the first image formed by this lens should be at the center of curvature of this mirror. But this mirror is the plane mirror. That's why, where do we get the image? At infinity. So as it is what infinity, so to form images at infinity, the rays should have to fall parallel. So once if it is what parallel, if the rays are parallel, where do we get the object? Object should be at the, so this one is what focus. That means, so this should be at the focus of that. Then what is the focal length of this one? 15. Therefore, this should be 15 centimeters. So that should be the answer for this one. And the opposite side of the mirror, this side it should be there. Therefore, this should be the correct answer, first one, right? So this is the way you have to remember. So very simple. As in the previous question, this is what convex mirror, we have taken what radius of curvature. But as it is a plane mirror, it is infinity. So this one is image should have to form at infinity. To form images at infinity, rays should be parallel. As the rays are parallel from the lens, the object should be at the focus. That's the way we can do. Right. Next, we go to the next one. Let us take, even this is, if two lenses plus 5 diopters are mounted at some distance apart, the equivalent power will always be negative if the distance is. We know that if two lenses, let us take what this is, either convex or concave, they are separated by distance d, the powers is P1, P2. So then what about the equivalent power is equals to P1 plus P2 minus d P1, P2 we can. So this is the way we can, and D should be in meters. Now let us take what even focal length also we can take 1 by F equivalent is equal to 1 by F1 plus 1 by F2 minus D by F1, F2 also we can take. Now, but as the powers are given, we can use this. But for convex lens, it is what positive. For concave lens, it is negative. Even power sign convention, even for focal length also. Then two lenses plus 5 diopters are mounted at some distance apart. Then, so what is asking? The equivalent power will always be negative. Then this is what negative is saying. Means P1 plus P2 minus D P1, P2 should be negative. The equivalent should be, this should be what? Negative. That means equivalent power should be negative. Negative means what is less than 0. And wherever P equivalent is there, I wrote this one. Then P1 plus P2, so that should be D P1, P2 we have. Then P1 plus P2 is, so P1 is plus 5 diopters, even both are the same. Plus 5 is what? Plus 10. So D into 5 we can write. So then we can take it as what? 10 is less than 25D, or we can write as what? 25D is less than 10, or D should be 10 by 25. Okay, so then we can take it as what? 10. So this is what? 5 twos are 5 fives are. This one. So then we can take it as what? Which should be? D is, this is in meters. D should be in meters. Therefore, 2 by 5 means what it is? So 0.4 meters. D is less than 0.4 meters, or in centimeters, it should be 40 centimeters. Therefore, it should be, so therefore this one is what? D should be So let us take what here. So this D should be greater than. So this one is what? D. What about the distance is less than? So this is what? 40. So then what is asking here? This should get the negative. So D should get negative. So once if it is what D is what should have to get negative, there this is equals to D P1 P2. So if I take what here, this equivalent should be less than 0. So as it is what less than 0, then we can take it as what this way. Then D should be what? It should be so 40 centimeters. It should be so that is what D should be like this should be there. Okay, right. So P1 plus P2 minus D P1 P2. So you have to, it should be, will always be negative. Negative means what? It should be less than 0. The next, go to the next one. Let us take, so another one, yes. So, and one more thing we have to, another important point. So let us take even, so each quarter of a lens of depth given h is filled with liquids of the refractive indices N1, N2, N3, N4 from the bottom of the apparent depth of the vessel. Whenever it is given, so this way it is given. So there are what? 4 given N1, N2, refractive indices N1, N2, N3, N4, and also H is filled with the liquids. So bottom of the apparent equal quarter. Equal quarter means what? This is total is H, this is H by 4, H by 4, H by 4, H by 4. And so each quarter is given. So from the bottom respective, the apparent depth of the vessel when looked normally. So what about the bottom as we are observing from the top? That means what we are observing from rarer medium. Then what we can take? What about in this? We know that T1 by thickness by refractive index plus T2 by mu2 plus T3 by mu3 plus T4 by mu4. So into what we can write, this apparent depth is equals to into. So this one is what? Thickness divided by its refractive index, thickness divided by its refractive index, thickness divided by its refractive index into. So this is, so observing medium. What is the observing medium is? This is what 1. Now I can take it as here. So simply H by 4 by N1 plus H by 4 by N2 plus H by 4 by N3. So plus H by 4 by N4 into, that is the observing medium, which is equals to 1. So this is what apparent depth of this one. When we look at it, appears this. Yes. Next, another similar question we discuss. Even a fish rising vertically up towards the surface of water with speed of 3 meters per second. So this, let us take a fish rising vertically. This is rising vertically with velocity 3 meters per second. Observes a bird diving vertically down with a speed of observed velocity. Observed velocity is 9 meters per second, but it's not the actual velocity of this one bird. The actual velocity of the bird is, we don't know, that is VB, but observing as 9, that appearing as 9. The actual velocity of the bird is the same way we can take. Then what we can write, either so distance by refractive index plus second distance by refractive index into mu of observing. Then this is what apparent velocity or observed velocity or apparent velocity is equals to. What is the actual velocity? This is 3 divided by, what is the medium of this? 4 by 3. And even this velocity is what? VB. By what is the actual medium of this one? 1. This is the actual velocity of the bird into observing medium. Which one is observing? So this is, so bird, this fish is observing. Fish is rising vertical, observes a bird. Then observing medium is 4 by 3. Then we can take it as what? Observed velocity is given in the question, that is 9. This 9 is not the actual, it is observing. Therefore, if you multiply this 4 by 3 cancel, that is 4 by 3 into VB. That 6 is equal to 4 by 3 into VB. 2 2s are 2 3s are. then VB is equal to 9/2. Then, so the actual velocity of that bird is 4.5 meter per second. So that's the way you can do this question. The important that is, so thickness by its refractive index or velocity by refractive index into observed medium gives what apparent or observed we get. So this way you can do questions. Right. Next one. Yes. Even let us see the final, that is, so the 2026 asked this question. Let us take a ray of monochromatic light passing through an equilateral prism ABC as shown in figure. Of course, figure it's not there. The refracted ray is parallel to its base. Let us take parallel to its base ABC. This is 2026. So on prism, so the refracted ray, so QR is parallel to its base. This is what parallel to its base, like this, parallel to its base. So the angle of incidence is 50 degrees. Then the angle of deviation is asking. Once if it is what angle of deviation, okay. So then it is an equilateral prism, that is 60 degrees, okay. Then, so angle of deviation is equals to what we can write? D is whenever, so light rays were parallel to the base, which is equal to, it's a minimum deviation condition. So therefore, minimum deviation is 2i minus a. Then, so which is equals to, then is asking about deviation 2 into 50 minus 60, which should be equals to, so this is what 100 minus 60, which is equals to 40 degrees. Okay, like that we can so discuss this prism. The things you have to remember. So deviation is equal to I1 plus I2 minus A, and the minimum deviation is 2i minus A, or mu is equal to sine of. These are the points you have to remember. A plus dm by 2 by sine of A by 2. This is the way you can remember. And also, whenever light rays, one last point, whenever light rays were falling normally, so and if it is grazing, whenever it is for normal incidence, I0 R0, whenever it is grazing, I becomes what? 90, R becomes so critical angle. So this is a way, so you have to remember these points, right? So anyhow, so we can stop here, and you can do the practice the questions, because they ask what in 2026. One is what lens and the prism, and this year we can expect what mirror definitely they can give. So or they can give what we cannot say, even prism again, and also lenses they can ask. Okay, so even so one more point, one last point we discuss. Even silvering of lens also we can take. Then yes, even we can take. Yes. So let us take what even the silvering of lens. If suppose if this is the plane mirror, So plane side is what silvered, it behaves as a concave mirror. So we can take it as what 1 by f is equal 2 times of lens and 1 time is the mirror. Then 1 by f is equal 2 into mu minus 1. So you have to remember, so this is what focal length is infinity. Then f is equal to r by 2 into mu minus 1. Should remember when plane side is silvered. Whenever curved side is silvered, then it becomes what 1 by f is equal to 2 into mu minus 1 by r plus. So this becomes what 1 by f. F is equals to r by 2, which must be equal to 2 mu minus 2 plus 2 gets cancelled, 2 mu by r, or f is equal to r by 2 mu. This is the way you have to remember. Whenever it is a plane side is silvered, then it act as a concave mirror. Of focal length is r by 2 into mu minus 1. If the curved surface is also silvered, it behaves as concave mirror of focal length r by 2 mu. Okay, so you just remember what these things anyhow. So we'll finish this this one session now. So we'll continue with the next another topic tomorrow. Right? All the best.